After detaching itself from the rover, Perseverance rover drove away, leaving the little helicopter to begin testing its systems so that it could begin its historic autonomous flight on another planet. After starting up the rotors and running through some more tests, it was discovered that a problem occurred which prevented the helicopter's rotors from transitioning to flight mode. A solution was relayed to the helicopter, and on April 19th, Ingenuity's rotors were started up. After reaching the appropriate rotor speed, Ingenuity's rotor blades were tilted to take a bigger bite out of the Martian atmosphere and begin flight. The solar-powered helicopter first became airborne at 3:34 a.m. It was the time of day that gave Ingenuity time to warm up after a cold Martian night, and winds were at their minimum. Ingenuity climbed to an altitude of 10 feet and maintained a stable hover for 30 seconds. It then descended, touching back down on the surface of Mars after logging a total of 39.1 seconds of flight. Ingenuity's initial flight was autonomous and piloted by its onboard guidance, navigation, and control systems. In honor of the Wright brothers and their historic flight on Earth, Ingenuity's takeoff and landing airfield was named Wright Brothers Field. The 19.3-inch tall Ingenuity Mars helicopter contains no science instruments inside its tissue box-size fuselage. Instead, the 4-pound rotorcraft's goal was to demonstrate whether future exploration of the Red Planet could include aerial observations. Images of the first flight were captured by the Perseverance rover with its Mastcam Z imagers from a vantage point of about 210 feet away. Before taking off, it checks with the instrument META on the rover for information on winds and weather data. Ingenuity's landing is a little different than on Earth. The helicopter takes off at 1 meter per second and descends at 1 meter per second. Ingenuity lands by flying directly toward the ground and detecting when touchdown happens. Ground is contacted at a relatively high rate of speed of 1 meter per second. To withstand these firm landings, Ingenuity is equipped with a suspension system in its leg structure. The second flight also took off from Wright Brothers Field, with an eye for accomplishing some bigger things. On the first flight, Ingenuity hovered 10 feet above the surface. For the second flight, the helicopter climbed to 16 feet. Then, unlike the first flight, after the helicopter hovered briefly, it went into a slight tilt and moved sideways for 7 feet. The helicopter then hovered in place and made turns to point its color camera in different directions before heading back to the center of the airfield to land. During the second flight, Ingenuity climbed to 16 feet, traveled 7 feet to the east and back, and remained airborne for 51.9 seconds. It also made 3 turns, totaling about 276 degrees. Flight 3 occurred on Sunday, April 25th at 7:16 a.m. The same altitude was attained, but things were opened up a bit more from there. Airspeed was increased from 0.5 meters per second to 2 meters per second. Ingenuity traveled 50 meters north and returned to land at Wright Brothers Field. Total flight time this time was 80 seconds and a total distance of 100 meters. That distance was significant because before this, the helicopter had only moved 4 meters laterally during Flight 2. There was a slight delay in initiating Ingenuity's fourth flight. Once again, the rotors failed to transition to flight mode, just like before the first flight. NASA tried again the next day, and the helicopter performed as planned. For Flight 4, the helicopter took off at 10:49 a.m., climbing to an altitude of 16 feet before flying south approximately 436 feet and then back for an 872-foot round trip. In total, the helicopter was in the air this time for 117 seconds. This time, a lot of images were captured during the flight with both Ingenuity's color camera and black and white navigation camera. About 60 images were saved from the fourth flight before it returned to its landing site. Some of the black and white images were taken as stereo pairs, allowing production of 3D images of the surface. Adding images like this could offer a broad range of scouting possibilities across places that rovers can't roam or close-ups that orbiters can't provide. During the fourth flight, for the first time, an audio recording was made of the helicopter in action. The fourth flight helped transition Ingenuity into a new phase, during which it showed its ability to serve as a scout for Mars rovers. Ingenuity's fifth flight took place at 3:26 p.m. on May 7th. It climbed to an altitude of 16.5 feet and cruised south for 423 feet, following the same path it followed during Flight 4. This time, however, the trip was one way. Ingenuity did not return to the Wright brothers' landing field. Instead, it took a 108-second flight and landed at a new location. Ingenuity's life was supposed to end after 30 days and a maximum of 5 flights. But Ingenuity performed so well that NASA extended its mission. With the completion of the fifth flight, Ingenuity proved that controlled flight is possible on the Red Planet. Ingenuity now has new orders: scout ahead of the Perseverance rover to assist in its search for past signs of microbial life. Keeping Ingenuity and Perseverance in close proximity is a logistical necessity, since the helicopter cannot talk directly to Earth, and all communication to and from the helicopter must go through Perseverance. The sixth flight was launched on May 22nd. Ingenuity's sixth flight included scouting multiple surface features from the air and landing at an even different airfield. The Perseverance rover could not record images of the helicopter in flight, as it was preparing for the start of the mission's science operations. Ingenuity's sixth flight plan began with the helicopter rising to 33 feet, then headed southwest for about 492 feet, with a ground speed of 9 miles per hour. At that point, Ingenuity began acquiring color pictures of an area of interest, traveling south about 50 feet. Stereo imagery of the sand ripples and outcrops of bright rocks at the site would help demonstrate the value of an aerial perspective for future missions. Approximately 54 seconds into the flight, a glitch occurred, and Flight 6 began to experience a major problem. Ingenuity began adjusting its velocity and tilting back and forth in an oscillating pattern. It experienced roll and pitch movements of more than 20 degrees for the rest of the flight. It experienced large control inputs and spikes in power consumption. Ingenuity, however, was designed to tolerate significant errors without becoming unstable. This design came to the rescue in Flight 6. Ingenuity's specially designed legs allowed the helicopter to withstand the hard landings. Despite such a significant problem, Ingenuity was able to fly 160 feet northeast and land safely within 16 feet of the intended landing location, known as Field C. Although such a stressful flight was not planned, NASA now has flight data probing the outer reaches of the helicopter's performance envelope. Ingenuity in Flight 6 flew at 9 miles per hour for 140 seconds. It was the first time that the helicopter landed at an airfield which it did not survey from the air. Going forward, this change in Ingenuity's mission means that flights will be more precise in maneuvering, greater use of its aerial observation capabilities, and more risk. Flights will also become less frequent. With Perseverance's short drives in the near term, Ingenuity may execute flights that land near the rover's parking spot. The helicopter can use these opportunities to perform aerial observations of the rover science targets. These scouting flights are a bonus and not required for Perseverance to complete its science mission, however. This new phase extends Ingenuity's mission beyond the original month-long demonstration. Now the goal is to assess how well flyers can help future exploration of Mars and other worlds. The type of reconnaissance that Ingenuity performs could one day also prove useful to human missions, by scoping out the best paths for explorers to traverse and reaching locations that aren't otherwise possible. The limiting factor for Ingenuity will be its ability to withstand the frigid Martian nights, where temperatures plunge to 130 degrees below zero Fahrenheit. Ingenuity's heater was only designed to last for a month, and engineers aren't sure how many freeze and thaw cycles it can go through before something breaks. But Ingenuity will definitely be grounded for good by late August. Perseverance will be wrapping up its planned science activities, preparing for solar conjunction, the period in mid-October when Mars and Earth are on opposite sides of the Sun, blocking communications.